All right, thank you. So yeah, this is going to be all about off-grid solar power. Haven't exactly timed it, so don't know how long we'll run, but I'll leave some time for Q&A at the end. I'll try to pace it so people have a chance to raise your hand if you want to get something in while I'm talking. But yeah, anyway, all right. So let's get started with field day because this is going to be fresh in everyone's mind. At least those were there would have noticed that we had a pretty good spread of solar panels out on the lawn and lots of wiring. Um, and so I wanted to, yeah, talk about that specific project really quick. So this year was the first time we crowdsourced solar power for field day. In past years, I want to say 2018 and 2019, we had a van with solar panels, or more of a trailer, I guess, that had panels and everything kind of built in, and we used that as like we would a tow behind generator. It was kind of a self-contained unit. That was sponsored by a company that doesn't seem to exist anymore. So we decided to revisit that. I think we were all getting tired of listening to the drone of the generator and smelling it and having to run over and restart it every few hours when it caught a whiff of its own carbon monoxide. So yeah, this ended up being part of our planning for this year. We had some great contributions from clubs, ACS and PSRG, especially, came together and donated a lot of gear. So as you can see, I guess in this picture, we have a few different clumps of panels. This works out to four separate series strings of panels that were each feeding into a charge controller, and those charge controllers were running into a circuit, a fuse bus, and then that was used to charge batteries, and we had an inverter. Um, I'll go into detail on these items, so don't worry if it doesn't make a lot of sense right now. But basically, we were running about 1,300 pound watts worth of panels. That's the rating. We got a little bit less than that, but I think we did pretty well. The charge controllers were set out in a waterproof case, just in case it rained, but we didn't really have any trouble with that. They were under this tent too. But yeah, we tried to make it flexible because we didn't know exactly what would happen when we got there. Um, as I mentioned just before the call, we had 12-volt batteries that were wired in parallel. We had 700 amp hours worth, or about 9 kilowatt hours. The battery monitor we ended up using wasn't calibrated because we didn't really know the state of charge of all of the batteries going into it. Um, so that was something that would, over time, learn the capacity of the batteries as we fully charge them and discharge them. So we didn't have the awareness, I guess, that we wanted to at the time. It also decided they were dead at one point overnight when we still had like 80% charge remaining. So that was fun to listen to. Anyway, yeah, so I was able to take my battery, which was in parallel, so it would have had the same charge level as the rest, and measured it at about 65 to 70%. So that means that we consumed under 4 kilowatt hours, and that was like a 12-hour period where the system wasn't producing power; it was just draining the batteries. And then as the sun came up and we observed it, we were getting about 800 watts into the batteries. Um, and that is on top of about a 250 watt load. So, I feel like we had a pretty good charging rate. We would have been able to keep going. Of course, if we were in wintertime, if it was overcast, it was rainy, we would have wanted a lot more. You want to call it over paneling, um, over what we expected because they're going to be producing significantly less power. So yeah, I think the consensus was that it was a success, and we want to keep going and see what we can do better next time. All right, so let's say why solar power. So reliability and disasters. It's fairly simple. There's no moving parts. You don't have to worry about spark plugs and um, oil changes and gasoline and all that, like you do with generators. The parts store, you can just throw it in your closet. You don't have to worry about any of that. It scales, so you can go down to a small folding panel that'll fit in a backpack, all the way up to, you know, big panels that two people can carry around, and um, really anywhere in between. It's renewable. I mean, the sun is beating down on the earth all the time, so taking advantage of that, why not? It's eco-friendly, as long as the panels are made responsibly. Um, and yeah, as I mentioned before, the equipment, you can just throw it in a closet when you're done. You don't have to change filters or drain oil. It's always ready to go as long as you've got sun. All right, so equipment specifics, let's talk about that. So these are some of the basics. You got your solar or photovoltaic panels, and I'm going to kind of refer to these interchangeably. I find myself switching back and forth based on the context as I was typing this out, but that's the part that converts light into electricity. Um, it's like a silicon crystalline structure. Um, there's some magic involved. I don't really want to get into that for this presentation, but there's tons about it online um, that you can read into if you're interested. Charge controllers are electronic devices that will take the electricity from your panels and make sure that your battery and your loads are running at a stable voltage, your battery is charging safely, is not overcharging, uh, and that you've got the correct voltages, because the solar panels are going to vary uh, greatly depending on the amount of light hitting them and the load. So yeah, batteries are pretty crucial. A big part of solar systems. It's possible to power some devices directly from solar panels, but generally not advisable unless they have a very wide input voltage and are tolerant of blackouts. Uh, an inverter is commonly seen, although not critical. That's going to convert the low voltage DC up to standard household AC to run common appliances. If you just need to have a TV or a computer for some reason, something that uses AC, that can be very helpful. You could also run small kitchen appliances for comfort, whatever. Circuit protection's important. You want to have that at different points of your system. Uh, DC in particular arcs very easily. So if you're running a string of a few solar panels, you could be pushing 100 volts DC. And if there's current flowing when you disconnect it, you might create an arc. Uh, so it's good to have circuit breakers that are designed for that to extinguish the arc and prevent fires. You want to have fuses and circuit breakers close to your battery, um, because the battery is, of course, a huge source of power. So any fault along that inside the charge controller and the wiring could cause short circuit and smoke, which is bad. So different types of panels. The ones we were trying to go for field day, and the ones that I generally recommend for cost-effective performance, is going to be this rigid style. So it's glass sheet. It's got a metal frame. It may or may not have this little kickstand. And this is typically what you're going to see on top of houses or commercial buildings that have solar installations, just because it's the cheapest way to get lots of power. Typically, these come in two different flavors. One of them is going to be monocrystalline, like you see here, which has kind of a black or dark blue appearance, very homogeneous looking, consistent color. And I've decided to call this the single malt scotch of cells because it's a single silicon crystal. Polycrystalline is a mixture of crystals fused together. Don't have a photo of that handy, but they're typically like a blue mixture of light and dark blues, and they sort of look broken, is a good way to describe it. But they're not necessarily broken. That's just what they look like because they're just a blend. So it's cheaper to make. They're a little bit less efficient, but there's nothing wrong with them if you get a good deal on them. They're totally fine. Solar panels are usually warranted for 20 or 30 years to provide, a certain level of performance, which is like 80, 90%. So if you find some surplus, polycrystalline cells, there's no reason not to get them, for a fixed installation. But if you're going to be carrying it around, you want to maximize your aerial density. Thin film is another type. Um, that's very popular. The cells themselves are flexible, so you can see they might roll up. A lot of people stick them on top of RVs or trailers because it can conform to the roof line. Um, they are usually uh, pretty low output compared to these fixed panels, so you will need more of them. And from what I've seen, ones that have been installed for a while are usually pretty cloudy and yellow because of UV damage to the plastic film on top. Glass is really the way to go. If you have a folding, like the backpack style, um, plastic is fine because it's not going to be out in the elements year round. You're going to probably have it at home unless you're using it. So not as big of a deal. Newer technology that is taking off. A lot of manufacturers are getting into bifacial. This isn't necessarily a different cell, but it's more of a different construction. So typically, solar panels you'll see will have a white or black background. That's a backing sheet, and it's what the cells are affixed to, and it provides strength and support. Um, but someone had the great idea of just sticking another piece of glass back there, which eliminates the backside of the cell and gets you more power. Um, some bifacial panels get, 15% extra power just by capturing the reflected light. And so they work best for like an awning or over a garden, something where there's some distance between the panel and the ground because it can capture that light. Especially if you have a white rooftop and you've got it stood up, it can capture more of that. You get more power throughout the day. You might get more peak power. So those are pretty cool. Um, Worth looking into. All right, the next major component is going to be charge controllers. So this is something you'll typically, you might see it with panels. They might come with a charge controller. Typically, it's going to come with a very cheap charge controller that's really the bare minimum you need to not fry your battery. I would recommend going with something a little fancier. Um, but I'll get into that later. The basics of why you want a charge controller is because solar panels, depending on the number of cells, are going to produce somewhere between 18 and 36 volts typically. They might be more. Some of them will output 40 or more if they're big and fancy panels. But on top of that, the output is going to be highly dependent on lighting conditions. So obviously, as the sun comes up and passes overhead and sets, and there's clouds and trees and bugs and stuff that get in the way and can affect the output. So anything connected to it, you want to have a stable voltage source. Um, and typically, batteries are not the same voltage as solar panels. So while typical batteries are going to be sized at 12 volts or 24 volt nominal, which works out to 12.8 or 25.6 or 48 volt. That's kind of a fixed range. It's got a very narrow operating range, and it's usually going to be lower than the panels you're running. So if you were to connect a panel directly to a battery, first of all, you're going to lose power because the solar panel is going to hit its short circuit current rating as its voltage drops to the battery voltage. So if you're talking about power, um, there is a graph I should have thrown in here, but solar panels have what's called an IV curve or current voltage curve, and that is it's sort of a continuum of which they generate a combination of volts and amps. So it's not a fixed power output. It's dependent on what it's connected to. Um, if you pull its voltage down, you're pulling its current down, you're pulling the total power down. So what charge controllers do is they allow the panel to operate at the voltage at which it's most efficient. So it's going to be outputting the most power. So if your panel just, for instance, is outputting 18 volts at its maximum power, the charge controller should be putting the appropriate load on it to keep it at 18 volts and delivering the correct voltage to the battery. So that is going to give you the best power output. So you can get close to the rating. PWM is one type of charge controller. They're low cost. This is what you usually get in a kit. And basically, it's just a switch. It rapidly switches on and off the connection between the solar and the battery. And it does that to regulate the current. I shouldn't necessarily say voltage because it doesn't really change the voltage, but it averages out the current to properly charge a battery. But they really are designed to work with systems where the battery and the PV voltage are very close to each other. So not you don't want to have a solar panel that's 40 volts connected to a 12-volt battery because it's going to be horribly inefficient, and it may fry your charge controller. You'll have to look at the manual. MPPT charge controllers, on the other hand, like the one here in the photo, for example, it's got these numbers 75 and 15. So 75 represents the maximum input voltage on this, and 15 is the current, either input or output. This is designed to charge a 12 or 24 volt battery, but you can feed it up to 75 volts DC on the input, which is going to be close to 3 of your small 100 watt or 200 watt type panels in series. That's super convenient. So it will pull it will put the correct load on the panels to get the most out of them, and it'll step that voltage down all the way from 75 to 12 if need be. Of course, you're going to be limited by the current on the output side in that case, but there's tons of different versions of this available. So they're fancy. As conditions change, as you connect panels in different configurations, they'll adapt and output the correct voltage for your battery. Typically, they also have Bluetooth. I think that's why this one's called Blue Solar. So you can remotely monitor it, control it. You can set those points. You can tell it what voltage your battery is and all that, and see your production throughout the day, which really helps with planning. So batteries are another crucial part of the system. As I mentioned before, this is what provides your stable voltage source. This is your main power. Um, of course, panels are going to be outputting anywhere from 0 to their rated voltage throughout the day for whatever reason. So whatever you're powering with it, if you want it to stay on, it needs to be connected to a battery. Let me just say lithium iron phosphate, or LiFePO4, also seen as LFP. This is by far your best choice right now. For, I gotta say, any application that requires 12 volts or 24 volts or 48. Lead acid batteries are kind of terrible. They got us along for a long time, but they have so many downsides. They have a very short cycle life by comparison. So the more you charge and discharge them, they're going to wear out after uh, just a few hundred cycles for really good deep cycle batteries. And if you deep discharge like a car starting battery, it's going to be maybe a dozen before you start to see some major effects. The other problem with lead acid is they have the Pukert effect, named after Pukert, um, which effectively means that as you increase the load on them, their effective capacity decreases. So if you have a 100 amp hour lead acid battery and you are drawing it down in an hour or two, so you're pulling um, a C1, or two, 1C or 2C rate on it, you are going to be effectively using a 50 amp hour battery. That's just how it works. The ratings that you see on the sticker are almost always over 20 hours. So if you take the capacity of the battery, divide by 20, that means if you have a 100 amp hour lead acid battery and you drain 5 amps, then it's a 100 amp hour battery. But like I said, if you increase that to 20, then you're talking C5 rate. You're going to be There's a whole equation to figure this out. But in the comparison is lithium iron phosphate really doesn't suffer from that at all. And anywhere up to an hour or less, you're not going to see any significant capacity degradation. 100 amp hour lithium iron phosphate battery can pretty much run 100 amps for an hour, which is a much more useful metric, in my opinion. So that's great. They can also cycle thousands of times. Calendar aging, they're still fairly new. It's kind of at the point where they've been around for a long time in terms of like 10 years or more, but we haven't really seen much degradation yet that I'm aware of, and so we'll see. But so far, they last a very long time. So higher upfront cost, but absolutely worth it if you can afford it. Inverters, like I said, they're not necessary if you're just going to be running an amateur radio because they're pretty much designed for 12 volts, but it's very handy to have, especially in an emergency situation if you just need to fire up something that's AC powered, and that could be a laptop too. There are ways to power laptops directly from DC, but they all come with an AC brick, so if you've got an inverter, that'll get you powered. Uh, you can also use it for comfort items like a blender if you need to, whatever. Um, Definitely want to stick with pure sine in terms of specific recommendations. Modified sine inverters output a very dirty square wave. Really, it's kind of between a square and a triangle, maybe a pyramid. Um, but generally, it's gonna make everything less efficient. It's gonna make stuff buzz and run hot. It's gonna introduce audio. I'm not sure, what it would sound like on the other end of a radio, but you can hear it yourself, so it's very annoying. And if you try to run a fan on it or an air compressor or something like that, it's going to be terrible. They run extremely hot. They take a long time to start up. So yeah, I'd also recommend if you find some that are UL and ETL listed, those are going to be safer, higher quality devices, generally lower RFI emissions. And I don't know why this is last, but circuit protection. I should move this up. Um, you want to have circuit protection everywhere you can. It's well worth it to avoid shocks or fires or smoke or whatever it is. Um, Example here is an inline fuse you can buy for solar panels. Um, when you connect solar panels in series, as I'll go into later, you don't increase the current, so you can size that fuse for whatever your panel is, usually within 10 or 15 amps or so. Um, for higher voltage strings, double pole circuit breakers designed for PV disconnect, like I mentioned arcing before. That's something that is going to make it safer when it's time to disconnect the system. It's going to make it safer if there is a fault where one of your high voltage lines is compromised, and it's going to prevent an arc there. Um, it's not critical if you're just running stuff in parallel, but I think it's a good idea because it allows you to just assemble and disassemble things safely. And then some general guidance on fuses and circuit breakers here. You want to be about 125% of what you expect, so 25% over. Um, and then your wiring should be appropriately sized for about a 3% voltage drop. But you can stretch this. This is kind of based on um, like automotive or boat wiring rules. So if it's just your radio, you can go a little bit smaller, but you will get better performance with if you keep it low. Um, Calculated that for a 20 amp load up to 6 feet, you could run 14 gauge wire. Up to 10 feet, you could run 12 gauge wire. Um, and there are some pretty good charts on this that you can refer to if you have any questions. All right, so how to connect it all. The first thing that you want to do is probably figure out what your solar panel ratings mean. So you'll see they will usually have a sticker like this. It might just be in the manual, but it's going to have all these funny numbers. So max power, operating voltage, operating current, short circuit voltage, and short circuit current. This spells it out nicely, but sometimes they don't. Pmax is the total effective power output of this panel at its maximum. The VMP means volts maximum power. And so 18.6 volts is the sweet spot for this in terms of power output. And then current at maximum power is going to be 10.76 amps. So these two numbers combined are what's going to give you the 200 watt output. And then these are for more planning purposes. So open circuit voltage is very important when you're connecting the strings together. This is the number that you're going to add together when you're sizing your charge converter or your charge controller. you want to make sure that the sum total of the volts open circuit does not exceed your charge controller's input. Um, there's a little bit more to this. Uh, if you stay 25% under your input, you should be fine. 15% is probably okay, but in some cases, the open circuit voltage will actually exceed this if the panel's cold. And there is another uh, there's more math that you can do to figure that out if you want to get really close and be really optimized and have something that you know isn't going to change. You can go through and do all that math, but I like to just give it a good safety margin. 15-20% should be fine. Short circuit current is what you're going to be hitting if you were to short it out or connect it to a battery that's much lower voltage. So for this panel, um, you could multiply, 12.8 volts times 11.47 and figure out how much power this would put into a 12-volt battery. Um, it shouldn't hurt the panel, but it might overcharge the battery if it doesn't have its own protections. So yeah, these are kind of the keys there. Basic wiring. Um, yeah, most people probably understand this, but yeah, solar panel goes into charge controller charges battery, battery provides your loads. So the inverter you can just think of as your load here. It doesn't have to be an inverter, but as you see, that's pretty common use case. This chart doesn't include any circuit protection, unfortunately, but it should be pretty much everywhere in here. Usually inverters will have their own, but it's really best to have a fuse as close to the battery terminal as possible to prevent any downstream issues from short circuiting. Okay, so series and parallel, you can wire up multiple panels different ways. There's trade-offs to each. So if you wire in series, which is generally what I recommend for larger installs, um, as you can see, there's very little wire waste. Each panel is going to come with one of these cables with what they call MC4 connectors on them. Those connectors are designed to plug into each other in series. So if you buy 3 panels, you can plug them into each other, and then you only have to make one return. It could be on the positive or the negative side, but you only have to make one return to your charge controller. So it simplifies the wiring. No matter how many you add in series, the current's going to be the same. So if it's 10 amps on one panel, it's going to be 10 amps on 3 panels, or in this case, 6 amps. If you want to wire them in parallel, which is kind of a necessity if you're going to run a PWM charge controller, or if it's just what you have on hand, you eat up more wire, but you can use power poles to do that, or you can use MC4 combiners, or you can use a DC combiner box. You can run each panel into its own circuit breaker and into a bus. There's lots of ways to do that, but keep in mind that however many you add, you have another set of wiring, and your total wiring going to the charge controller current is going to increase. So you need to make sure that's big enough to handle it. If the panels are located far from your charge controller, you need to size up your wire to keep the voltage drop down. So it's possible to mix panels if that's what you've got. If you have 200-watt panels, and if you have 200-watt panels and the current, the VMP or the IMP is off by a couple of volts or amps, you can connect them together in either series or parallel. But the smaller of either of those numbers is going to affect the total system output. So if you connect them in series, you're always adding the voltage together, but your current's going to be limited to whatever the lowest value, and uh, the opposite for wiring them in parallel. Um, there's probably some nuance to that as far as the charge controller is concerned. It might not be able to hit that maximum power point. It might be a little lower than ideal, but it is possible. It's probably not going to hurt anything, but if you're planning out a more permanent installation or longer term configuration, you want to try to avoid that and either buy all the same panels or buy a separate charge controller for each set of panels that you're connecting to get the most out of it. So let's see. Some other considerations, of course, probably a lot of people here are wondering about portable setups for parks on the air, summits on the air. You can buy these smaller folding panels. You can buy small batteries, small charge controllers. Some small panels have charge controllers built in that'll handle a phone. Um, Bioenno is a common source of batteries. They seem to be very good quality and a good form factor for a lot of packable stuff. But I noticed that as they scale up in size, they scale way, way up in price. And if you, I would just recommend personally, if you're looking for a pack that's like 10 amps or bigger, you can save a ton of money by not getting Bioenno. No offense, I'm sure they're great, but they offer the best value in these smaller configurations. They also tend to have these separate charge leads, so you can't just connect one thing. Um, you'll have to put your load on one side of it and the charger on the other side of it. Small packable panels like this exist. They can charge phones. They might have MC4 connectors, but usually it's going to have a different connector. So when you start looking at these, you'll have to look a little closer. They might have what's called an XT60 connector, which is a yellow. Um, it was kind of designed for RC cars and planes. Personally, I don't really like them. They are more difficult to assemble than MC4 or power pole where you're crimping. They pretty much require you to solder them. Um, it takes a lot of heat, especially with larger wires, to get them to solder well. And they also require heat shrink or some kind of boot to protect the connection. They don't snap together cleanly like power poles. So just keep that in mind. Let's see. If you're shopping on Amazon and you come across folding panels that are rated like 5 or 10 or 15 watts, I would just skip it because even if you lay it out in the sun with your phone connected to it, it's going to struggle to charge. Same goes for really like the battery power banks that have solar panels on the side or flashlights and radios that have solar panels built in. It's really a gimmick. It might kind of work, but you don't want to leave batteries charging out in direct sunlight anyway. So if you can get the panel and the battery separate, that's going to be better and it's going to be a lot more effective. Um, Another thing that's getting really popular now are these all-in-one power stations or solar power stations or solar generators. It's got a lot packed in there. It's super dense. The value is getting better all the time. The features are getting better. Um, it's amazing what these can do. So a unit like this, you can often find on sale for 500 or 600 bucks. And that includes 1800 watts of pure sine power that I mean, you could run a microwave on it if you wanted to. It's got power delivery, so you can power computers directly from it. It has, I think this one has 500 watts of PV charging, so you could connect um, a lot of solar panels to it, enough to charge it up in a couple of hours of direct sun. And it will do rapid charging from 120 volts too if you have grid or generator available for a brief time. It's a good portable option. So yeah, those are pretty cool. A lot of brands are getting into it. They also typically have Bluetooth, so you can remotely control them. So weather is, of course, an important consideration. Lighting conditions vary greatly. Um, from my observations, on an overcast day, I typically see about 10%. So if my system can generate 1 kWh on a clear sunny day, 100 watt hours on a rainy day or overcast day. If it's raining, it could be less. It might not even charge at all if you've got dark storm clouds. So you want to plan for that eventuality, especially here where the sun's going to be moving a lot. In wintertime, you could go for quite a while without generating much usable power. Edit mode. So one thing you can do to get around that, or to mitigate it, is to just run more panels in parallel. Um, in that case, you don't want to run them in series because your voltage is going to be varying too much, but you can run a lot of extra panels in parallel into an MPPT controller, and it's never going to pull more current than it can pull or deliver whatever its current rating is. It's just going to stop because it's a electronic smartish variable device. So you can always just scale out. Um, they're very durable generally. The folding ones are pretty durable too, but they might have fabric or plastic components. But the rigid glass and aluminum ones are really made to take a beating. They can be on your roof. I've seen one drop down concrete, didn't suffer anything. So yeah, you can leave them outside. The connectors internally shouldn't be left open, but when they're mated, they're waterproof. Um, and then I also want to throw in that a lot of MPPT chargers can also connect to wind turbines or hydro turbines if you've got that. So if you are in somewhere where you don't have a lot of light, but you have wind, you might be able to just swap out your panel for a wind turbine and run that into your charge controller also. Okay, so let's take a break for questions. I tried to keep it kind of high level, but if anybody has something they want to dig into, let me know.
So Matt, this is Carl. Would you go back to the overhead picture that was on your first slide, I think?
Yeah, there.
Okay, and just for the benefit of everybody looking at this, you've got basically four different sets of solar panels feeding into four separate charge controllers.
Right.
Because of the different voltage ratings of the different panel, you tried to keep brands and models paired with each other and then into a single charge controller and then the next set, et cetera. Would you touch on that just a little bit?
Yeah, so it happened that most uh, people who contributed things, yourself included, thank you, had pretty similar equipment. So we have two identical panels here connected in series, four identical panels connected in series here, two identical in series here. These two were, I believe they were disconnected for most of the time. And then I had these dissimilar panels, which were also all connected in series. So that allowed us to keep the voltages within the ratings of each charge controller. We were using charge controllers that were mostly were donated by Midnight Solar. We had a couple on hand from the club, but it was easier to use the same equipment across. So we tried to utilize those as much as possible. They were rated for 150-volt input. So um, for I think the highest voltage string was these four panels here, which have an open circuit current or open circuit voltage of about 22 volts. So we were running 85 volts, I think. Still within their limit, but that was the highest. And then I brought this set of panels. I wanted to see how they performed connected in series, even though they're completely different brands. And two of them are rated 110 watts and two are rated 100 watts. They worked fine. They ran all day. They performed fairly well. And as expected, they were coming in at about 60% of the rated capacity because of that difference in voltage or a difference in current between them. So, yeah, does that answer, Carl?
Thank you, good explanation. And I'll comment from my own experience. You know, I bought a couple of solar panels. I bought a solar panel, foldable, portable. And then about a year later, I bought another one, and then I bought another one. And I was only moderately satisfied with what I was buying. So I switched brands and bought another one of a different brand. And it actually performed better than the ones that I had before. And then I bought another one of those. So I've got a hodgepodge of panels. My suggestion to anybody who hasn't started down this road yet is think about what your goal is, think about where your end point of this endeavor might be, and try to identify the solar panels, but charge controllers and batteries in advance that are gonna serve that purpose. And then
Yeah.
save yourself a lot of grief and time and money and standardize on each of the components that you buy so that it best serves your end goal.
Yeah. Yeah, I would say if you're just starting out, the first thing you want to do is just figure out what your power requirements are. So you want to decide on how many watts you need. And you want to figure out how big of a battery you need to run those watts for X amount of time, and then start looking at panels. So I would find, solar panels that are durable, well rated, have the physical size that you're looking for and the output that you're looking for, um, and then just get the number of those that you need, and then look at your voltages essentially, figure out what the total voltage is going to be, and then start looking for a charge controller that will work within that voltage range. And then you, of course, can decide on your battery voltage. If you're using an MPPT charge controller, there's some flexibility. Um, but you'll find that if all else being equal, if you have a 24-volt battery connected to the same charge controller, it's going to be able to accept twice as much power as a 12-volt would, because your hard limit is the current. It's going to be the current on either the input or the output. If your panels are 100 volts, your your battery current is going to be the limitation.
And a word of caution, and I think you mentioned this, but just to emphasize, charge controller voltage input is a limit you don't want to exceed. You can damage or destroy your charge controller if you put too much voltage into it. But as you noted, if you have more current available to it than it's rated, it's going to regulate so it only outputs up to what it's rated to handle.
Yeah, yeah. You never want to exceed the input voltage on the charge controller. And some of them will have a small buffer where you can go over without damaging it, but it will shut off. So, yeah, don't even bother. Any other questions?
Matt, can you hear
Yeah.
me?
Yeah, I can hear you.
This is Bob Kadama, KF7 SPA. I have a small refrigerator. It says 100 watts running. So how big a battery and how many panels do you think?
Well, refrigerators are tricky because the the power rating is going to be how much the compressor is pulling when it's already running. So watts running is not super helpful. The
It
two
said
things that you want, sorry, what?
it said 1/20th horsepower, if that's any makes any difference.
Yeah, if it's an AC fridge, that does make some difference. That's another rabbit hole. But in the simplest thing you can do is measure the watt hour consumption. Just
Okay,
because refrigerators will cycle to maintain a temperature delta between the inside and the outside. So the efficiency of the insulation, or the
right.
efficacy of the insulation, and the temperature it's set at and the ambient temperature are all going to dictate the 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 energy consumption. So power draw is instantaneous. Um, that 100 watts, if the compressor was running 24 hours, you could use that, but the actual consumption is going to be probably much less. And for an AC compressor, you also need to consider the startup draw will be higher. For a few milliseconds, it's going to be much higher while the compressor starts up every time. So your battery and your inverter are going to need to take that load, and then you'll have to figure out how long you want to run it and exactly how much energy it requires.
Okay. I liked your little cooler setup you had at field day. That was nice.
Yeah, yeah, that works well. And that's designed to run on 12 or 24 volts DC, so
Okay,
it stays within a low power envelope.
good. Thank you.
I've got a raised hand from Larry.
Yeah, I just thought it was interesting that I'm learning all this about solar power that I don't know, so I'm learning it. But at the same time, I learn how my refrigerator works. Thank you.
Yeah, you're welcome.
So
Hey, Matt.
is,
So
sorry,
Sorry, this,
two people talking.
this is Jeff. I'm sorry, did I interrupt somebody?
no, go ahead.
Okay, Matt, on field day, did you use very many inverters? Do you find that would come in useful?
Oh, we only used one inverter. So we had a 2000-watt inverter donated by
Oh,
someone. So that
mhm.
was easily able to handle everything. The only time that we exceeded 1000 watts was when we connected a commercial power station to it and it charged itself rapidly. Didn't cause any problems, but that was the highest power we saw. Typically, we were pulling between 2 and 400 watts.
Okay, so really the 12 volts that you had pretty much covered all the equipment and you just had one specialized use for the inverter.
No, actually, for field day, what we did, I didn't cover this, but we actually ran AC 120 volts out to all of the stations, and all of the 12-volt equipment was powered by standard bench power supplies. And the reason that we did that is because we already had a ton of extension cords, and if we were trying to distribute 12 volts to all of the stations over a 100-foot run, we would have had to use massive cables
Yeah,
to
yeah,
avoid losing power. So we just decided to keep it all high voltage, and all of the low voltage was in that the area in the picture.
okay. Okay, thank you.
Yeah. And then Bob?
Yeah, does batteries matter what brand you get? Just
Yeah,
as long as they're lithium or
lithium is generally better. Brands do matter to an extent. There are there are more brands than I can count. It seems like there's a new brand every day, so it's hard to know what to go with. I've been impressed with Lead Time, Litime. Some other good brands are um, Battleborn, Dakota Lithium. I've got some links that I've got in the last slide. I can show these websites, and then I'll make this available to whomever wants it. Maybe we could just put it on the PSRG website. But these are all stores that sell good quality stuff. Power Eurus is one that people seem to like. Um, I would stay away from the cheapest ones generally because what tends to happen is the companies will cut corners in the construction. So they're lithium, but they might be buying used cells that have been in EVs or in industrial UPSs. So they might not be perfectly matched. They might have years of use on them already, and they'll package it up, and they might be held together with a lot of like foam and glue instead of proper brackets and screws. So um, the top link there, DIY Solar Forum, um, that forum has a lot of reviews and teardowns, so people will actually take a saw and cut the top off the battery and pick it apart and look at the construction. So the ones that I recommend here, like Lead Time and Power Eurus, are going to have more robust construction. They might have laser welded terminals. They'll have thick copper bus bars internally, where the other ones might have thin wires, bad insulation, bad low quality battery management boards and stuff like that.
okay.
Carl?
Got on
Carl?
mute. I noticed that, of course, you were using donated equipment from a variety of sources, but you ended up with, I think, 3 or 4 different brands of batteries and at least 2 different sizes of batteries. You had one very large, and then the rest, I think, were all 100 amp hour, and they were all in parallel, and it was working quite well. I had always
Mhm.
Oh my goodness, you can't mix brand A and brand B and do this, but you demonstrated quite effectively that you could, for a matter of fact.
Yeah.
Did you see any problems or did you have any concerns at all about paralleling different brands of batteries?
No, I didn't. Because they were all 4-cell lithium iron phosphate. They all have a nearly identical characteristic voltage. The voltage is really determined by the chemical makeup of the battery and not by the manufacturer. It's so all of the cells are a nominal 3.2 volt, and the high cutoff is about 3.65, and the low cutoff is going to be about 2.5, and that's really, constant. There's some variables in the way that the battery management boards are programmed, but nothing that would compromise the safety of the system. So, I mean, it might cut one of them out of the string if it didn't like the voltage that the rest were at, but that would only um, slightly degrade the capacity until the rest of them came back down, for instance. So yeah, they're pretty safe. All of these lithium batteries have a circuit board with a microcontroller inside that monitors the temperature of each cell, the voltage of each cell, the total current in and out, um, and they have safeguards, or they should. I mean, if you buy the decent brands, they have safeguards against overcharging or charging when they're cold or charging when they're too hot. Um, if one cell starts dropping too low, the whole thing will cut out for safety until you connect the charger to it. So they're pretty safe. Most of them even have a short circuit protection. So you could take and I'm not going to recommend anyone do this, but theoretically you could take a cable and just short the terminals out and it would disconnect within microseconds until you remove the cable.
I think that first link you have, that's Will Pross, isn't it? That does all the teardowns and reviews. That's a great site, a
Yeah.
ton of information. One of the things he's noted about batteries in his teardowns, some of the differences between the more expensive batteries and the cheapest ones are whether or not they have the cold uh, charging cutoff
Yeah.
protection, things like that. So while the battery in normal operation and normal environments is going to seem to perform just fine, the better batteries will have more protections for the adverse environments that you put them in, things like that.
Yeah. Yeah. Lithium iron phosphate are particularly sensitive. They should never be charged below freezing, below 0 Celsius. Um, and some batteries will or will not cut out charging at that point. Um, for me, most applications, I can kind of control the temperature of the battery, but if you have something that's out in a shed or a toolbox in your yard or um, maybe on a mountain remote site, you would want a battery that has that protection built in. Otherwise, it can really, yeah, degrade the performance of the battery and kill it eventually. So that's a good call out there. I was thinking something else. Yeah, some of them will have other protections. Some of them have internal heating too, so they will heat up. Uh, there's they have a couple hundred watts of heating capacity, I think, when there's a charger connected. So it's not going to just drain the battery for the heck of it, because you can still discharge it down to about -20 Celsius. But if it's in cold weather, the first thing it'll do when you connect a charger to it is use whatever excess power it has to bring the battery up to temperature, and then it will start charging. So they're pretty smart. Those are more expensive and fancy, but certain applications, it's a great idea to have. Um, oh, the other thing I was going to say about the battery management systems is most, even though they have a single common port for charging and discharging, the computer can individually switch charging and charging. So they have a set of MOSFETs that are connected in different directions, like diodes. So it can it can block charging and still allow discharging, or vice versa. depending on the conditions.
Another question, Matt.
Yeah.
What is the most important thing you learned this year that will affect how you approach this task next year?
So I think the performance was good, but what I was most interested in fixing is the monitoring and visibility portion. Um, we didn't have a good idea of how much we were producing and consuming over time. I could check it, I could spot check it, but um, I would have liked to know a lot more about our total daily and nightly consumption. Um, and I also feel like we could have had better circuit protection built in. It wasn't a problem because there were plenty of fuses, but I would have liked a way to disconnect the solar strings individually. But yeah, I think we did fairly well. As far as advice for others, I would say there weren't enough MPPT charge controllers floating around. So that's what we ended up sourcing from Midnight Solar. A lot of people had batteries and panels, but the charge controllers they had were sort of the low cost ones that come with them. Um, and I would say that would be something that people could look at, make sure that you have a good charge controller. And PowerWorks actually has some very good small ones that are 150 to 300 watts. So they'd be great for one or two panels in parallel or 2 to 4 panels in series, or like 2 to 4 in like a series parallel configuration. They're actually very cheap. They're $30 or $40. They don't have some of the fancy features like monitoring or variable battery voltage, but for a 12-volt system, they actually work great and they're very portable. All right.
Any
Well,
other
we're at
questions?
2:30, so
Matt, when would you go to 48-volt batteries?
when would I?
Or when would you use 48 volts? Or how,
Well, in general,
y-
I like 48 volts.
I
I
think you said
would,
something about the wiring, it's smaller or something, or
yeah. So if you're running, if you're comparing 12 volts to 48 volts, given the same power levels at 48 volts, your current is going to be 1/4 of what it is at 12. So it means you can run smaller wires, smaller connectors, smaller fuses. It's easier to bend and run 10 gauge wire than 4 gauge wire. So if you can do that, that's great. Um, it has a slightly higher base cost because you need more cells, but and battery cells, I mean, and you need solar panels that are a bit above it. You want to have I think, what 15-20% voltage of your panels over your battery. So if you're running 48-volt batteries, you don't want to have 18-volt cells because or 18-volt solar panels because it won't be able to boost the current or the voltage enough to charge the batteries. You want to have 80 volts worth of solar panels connected to a 48-volt battery. So yeah, it's typically going to be for larger, higher power installations. If you're only running 200 watts, it really doesn't make any sense because you can still get away with 10 or 12 gauge wire for that, and your loads are going to be pretty small. A 300-watt inverter isn't going to need very big wires. But if if you were going to build something that needed to deliver 1 to 2,000 watts all the time, I would definitely go 48 volts if building from the ground up.
okay.
Matt?
Yeah, go ahead.
Yeah, it's Jeff, AB6MB. And this last time at field day, did you have somebody that was in charge of all the power to kind of coordinate it? And if you didn't, would you do it, have somebody in charge in the future?
Yeah, that was pretty much me because kind of volunteered to do it. But I would really like to get a small group of people, a team together to knowledge share and kind of manage it. There were people there who were fairly knowledgeable and knew kind of what was going on. But I don't know that anyone would have necessarily had the right steps to take to fix an issue if you ran into it, which was kind of making me nervous, but I was there the whole time. Um, and in the future, yeah, I'd definitely like to get it documented well and get some other people trained up on it.
Okay, good job, by the way.
Thanks.
All right. Well, if there's any other questions out there, if not, thank you, Matt, for the great
Big thank you,
presentation. That
Matt.
was very informative.
Yeah, you're welcome. And yeah, you can find me on Discord if you've got further questions.
Yep.
Matt, are the
Yeah.
Harbor Freight panels any good?
I'm not sure. I don't tend to go to Harbor Freight, but most things, they're probably sourcing them from another OEM. I don't know who, but it may be worth testing.
Okay.
Harbor Freight's kind of hit or miss. I know they make
Yeah.
some things, or they sell some things pretty well, and some not so much.
All right. Well, thank you so much, Matt, for presenting. And thank you, everyone, for attending.
Yeah, thank you.
All right.
Carl,
I'm going to
Yes.
stop recording now.
are you a motorcycle guy?